Define phase, basics of Six Sigma, general history of Six Sigma and continuous improvements. The Juran Trilogy. Juran has felt that managing for quality requires the same attention that other functions obtain. Thus, he developed the Juran or Quality Trilogy, which involves quality planning, quality control, and quality improvement. Juran sees these items as the key to success. Top management can follow this sequence just as they would use one for financial budgeting, cost control, and profit improvement. For any project, quality planning is used to create the process that will enable one to meet the desired goals. The concept of quality control is used to monitor and adjust the process. Chronic losses are normal in a controlled state, while the sporadic spike will initiate an investigation. Eventually, only quality improvement activities will reduce the chronic losses and move the process to a better and improved state of control, and that's the last word. Dr. Walter A. Shewhart, 1891 to 1967. Dr. Shewhart held a B.S. and M.S. from the University of Illinois and a Ph.D. in physics from the University of California. Dr. Shewhart's awards include the Hawley Medal, ASME, Honorary Fellowship of the Royal Statistical Society, First Honorary Member of the American Society for Quality, Honorary Professor of Statistical Quality Control, Rutgers University. The Shewhart Medal is awarded in his honor. Notable articles and books include: he published a series of articles in Bell System Technical Journal, Economic Control of Quality of Manufactured Product, 1931, Statistical Method from the Viewpoint of Quality Control, 1939. Dr. Shewhart worked for the Western Electrical Company, a manufacturer of telephone hardware for Bell Telephone, from 1918 until 1924. Bell Telephone's engineers had a need to reduce the frequency of failures and repairs. In 1924, Shewhart framed the problem in terms of an assignable cause and chance cause variation, and introduced the control chart as a tool for distinguishing between the two. Bringing a production process into a state of statistical control, where the only variation is chance cause, it is necessary to manage a process economically. Shewhart worked to advance quality thinking at Bell Telephone Laboratories from their foundation in 1925 until his retirement in 1956. Shewhart's charts were adopted by the American Society for Testing and Materials, or ASTM, in 1933. The charts were used to improve production during World War II in the form of American War Standards Z1.1, Z1.2, and Z1.3. W. Edwards Deming championed Shewhart's methods, working as a consultant to Japanese industries from 1950 to 1990. Walter Shewhart's statistical process control charts have become a quality legacy that continues today. Control charts are widely used to monitor processes and to determine when a process changes. Process changes are only made when points in the control chart are outside acceptable ranges. Dr. Deming stated that Shewhart's genius was in recognizing when to act and when to leave a process alone. The Shewhart cycle. The historical evolution of the PDCA problem-solving cycle is interesting. Kolsar states that Deming presented the following product design cycle, which he attributed to Shewhart, to the Japanese in 1951. Design the product with appropriate tests. Make the product, tested both in laboratory and production. Put the product on the market. Test the product in service through market research. Redesign the product in light of consumer reaction and continue the cycle. Perhaps from this concept, the Japanese, Mizuno 1984, evolved a general problem-solving process called PDCA. Both PDCA and PDSA are reviewed in Primer Section 1X. Dr. Jenichi Taguchi, 1924 to present. Dr. Taguchi is currently a consultant for Okan Associates of Tokyo and was the past director of the American Supplier Institute, Incorporated. He is called the father of quality engineering. One of his profound statements on quality is, quality is related to the financial loss to society caused by a product during its life cycle. Dr. Taguchi's numerous distinctions include the Deming Prize 1960, the Rockwell Award 1986, MITI Purple Ribbon Award 1989, Indigo Award, Japan, 1989, ASME Medal, 1992. Dr. Taguchi's notable books include System of Experimental Design, 2 volumes, Introduction to Quality Engineering, 1986, Offline Quality Control, 1979. Quality engineering techniques were developed by Jenichi Taguchi in the 1950s. The techniques enabled engineers to develop products and processes in a fraction of the time as required by conventional engineering practices. He made his first visit to the U.S. in the summer of 1980 to assist American industry in the pursuit of quality. In 1983, Ford and Xerox began to promote Taguchi's system, both internally and among suppliers. Taguchi's system was appealing because it was a complete system that started with the product concept and continued into product design and into the manufacturing operations. It is a system to optimize the design of products and processes in a cost-effective manner. Taguchi's plan takes a different view of product quality. The evaluation of quality. Use the loss function and signal-to-noise ratio as ways to evaluate the cost of not meeting the target value. The traditional view is that a product is either in specification or not. Taguchi feels the quality loss increases parabolically as the product strays from a single target value. Improvement of quality and cost factors. Use statistical methods for system design, parameter design, and tolerance design of the product. The methods could include quality function deployment, signal-to-noise characteristics, and design of experiments, using orthogonal arrays. Monitoring and maintaining quality. Reduce the variability of the production line. Insist on consistency from the floor. Take measurements of quality characteristics from the floor and use the feedback. Taguchi methods and other design of experiment techniques have been described as tools that tell us how to make something happen, whereas most statistical methods tell us what has happened. Taguchi methods are concepts that many engineers can take out of a book and use. The concept of robust products is now being explored in the design phase to reduce quality losses. Robustness derives from consistency. Robust products and processes demonstrate more insensitivity to those variables that are either ill-controlled or uncontrollable. Building parts to target, or nominal, is the key to success. One should work relentlessly to achieve designs that can be produced consistently and demand consistency from the factory. It has been published that about 50% of the practicing engineers in Japan are competent in Taguchi methods. Dr. Taguchi has presented America with quality engineering techniques that can work to produce better products and reduce costs. It is more technical in nature and made for technical specialists. Top management needs only to provide the training to learn the concepts and allow its use throughout the corporation for it to be effective. The Taguchi approach does not call for an internal revolution. His concepts do improve products and procedures. Bill Smith, 1929 to 1993. Bill Smith was Vice President and Senior Quality Assurance Manager for Land Mobile Products Sector Motorola when he introduced Six Sigma as a measure of quality in 1986. At that time, he was handling an increasing number of complaints from the field sales force regarding warranty claims. Motorola's product line was a complex one and operating near 3 Sigma level. At that level, it was producing too many defects. Mr. Smith determined that quality levels beyond 3 Sigma were necessary. He suggested a 1-6 Sigma level, allowing for plus or minus 1.5 Sigma shift. Mr. Smith helped Robert W. Galvin, Chairman and CEO of Motorola, recognize the need to control variation and to work toward 3.4 defects per million, or for 6 Sigma levels of quality. Later, with Michael Harry, Smith developed the initial 4-step 6 Sigma stages: measure, analyze, improve, and control, to reduce the defect levels. In 1988, Motorola won the first Malcolm Baldrige National Quality Award. Mr. Smith's 6 Sigma efforts were credited with achieving that award. Upon his death in 1993, Northwestern University and Motorola established a scholarship to honor Bill Smith. Michael Harry. Michael Harry and Richard Schroeder founded Six Sigma Academy in 1994 as a consulting firm specializing in the Six Sigma methodology. Michael Harry has called Bill Smith the father of Six Sigma and gave himself the title the Godfather of Six Sigma. Many industry people have called Michael Harry the main architect of the Six Sigma movement, as he has been the most widely known driver in the industry. In 1985, Michael Harry joined Motorola as a quality and reliability engineer, where he initially developed a problem-solving program that included Juran's Quality Journey, SPC, Shannon's tools, and planned experimentation. He later teamed with Bill Smith and developed the MAIC methodology with the logic filters approach. The logic filters are a collection of tools to be used at each stage of the problem-solving approach. These originated from Harry's research at Arizona State University. In 1989, Robert Galvin gave Harry the head position for the new Six Sigma Research Institute at Motorola University, where the emphasis and focus would be on dollars, business transformation, and building a foundation for the Six Sigma process. During the process of building the Six Sigma structure, Michael Harry and a Unisys plant manager derived the term black belts for the new breed of statistically trained problem-solving experts, as they were both martial arts enthusiasts. Forrest Breyfogle. Forrest Breyfogle III is the founder and CEO of Smarter Solutions Incorporated, based in Austin, Texas. The company was formed in 1992 to provide training and consulting services for the Six Sigma methodology. His integrated system applies the principles of strategic planning, metrics, ISO 9000, theory of constraints, lean, and processes in conjunction with Six Sigma. Forrest has a BS in mechanical engineering from the University of Missouri at Rolla and an MS in mechanical engineering from the University of Texas. Mr. Breyfogle is a professional engineer, an ASQ Fellow, and a recipient of the ASQ's Crosby Medal for implementing Six Sigma Second Edition, which made a significant contribution to the understanding of Six Sigma. Basics of Six Sigma, deliverables of Lean Six Sigma project. Embarking on a Lean Six Sigma initiative begins with a management decision to embrace a change that says, there's a better way to run our organization. The readiness assessment includes a review of the following areas. Assess the outlook and future path of the business. Is the strategy course clear for the company? Can we meet our financial and growth goals? Does our organization respond effectively to new circumstances? Evaluate the current organizational performance. What are our current overall business results? How effectively do we meet customer requirements? How effectively are we operating? Review the capacity for systems change and improvement. How effective are we in managing system changes? How well are our cross-functional processes managed? Are our current efforts in conflict with Six Sigma? The above assessment will go a long way towards deciding if current efforts are sufficient or whether the timing is appropriate to undertake a Six Sigma effort. Lean Six Sigma can be applied as a targeted approach. A number of so-called Lean Six Sigma companies have improvement techniques and teams in place and only assign black belt assistance as needed. A decision on Six Sigma might be negative if the following conditions exist. The company already has an effective improvement effort in place. Current changes are already overwhelming the company's resources. The potential gains aren't sufficient to finance the necessary investments.